So for this one, let's practice a series circuit. We want to calculate the overall current and the voltage in each. And so remember, the first thing we got to do is bring them all together into one. And then once we do that, we know that, we bring them all together into one. Once we do that, we can then say, okay, well, once we find the current, we know that the current's going to be the same in all three, right? Because as the charge goes through, it's got to pass through all of these, right? The same speed of the current all the way through. So yeah, go ahead and pause the clip and give this a try. When you're ready to check, you can hit play. All right, so you should get 1 amp, and then 5 volts for the first one, 3 volts for the middle one, and then 4 volts for the last one as the current passes through, and the current's the same in each. Let's go ahead and try this one here. This is a parallel circuit. The top one is 4, the middle one is 19, and the bottom one is 22 ohms. And the 24 volt cell, we want to find the overall current. And then we want to find the current in each one. So yeah, see if you can remember how to do that. And go ahead and get it all the way up to the overall current, and then we'll break it up into 2 parts here. So go ahead and try this one, and then pause the clip, and when you're ready to check, you can hit play. All right, so 2.87 ohms. Bring them all together. 1 over 4 plus 1 over 19 plus 1 over 22 equals 1 over Req. And we have to cross multiply and divide. We get the resistance, and the overall current should be 8.35 amps. Now, if you remember with parallel circuits, each of these get full voltage. They all get that full 24 volts going through, 24 volts, 24 volts. So therefore, we can find the current in each. And so each gets that full voltage river that we have established there in that unit that we talked about. So yeah, go ahead and pause the clip and give this a try, and when you're ready to check, you can hit play. All right, so top one 6 amps, middle one 1.26 amps, and the bottom one 1.09 amps. All right, so why don't we try this one here, another series circuit. We want to find the overall current and the voltage in each. So yeah, go ahead and pause the clip and give us a try, and when you're ready to check, you can hit play. All right, so we'll bring them all together, 29 ohms, and the overall current is 0.414, and we know that the current will be the same in each. So the first one will be 3.72 volts, 4.55 volts, 1.24 volts, and 2.48 volts. Let's try a parallel. So this one is the 4 ohms on top, 3 ohms. They're in parallel, 4 and 3 ohms, and then a 15 volt cell. So we want the overall current, which is this. We want to find the current up here and the voltage across the 4 ohm resistor. So go ahead and pause the clip and give this a try, and when you're ready to check, you can hit play. All right, so we should get the overall the overall resistance 1.7143, and then the overall current should be 8.75 amps passing through, and then each of them gets a full voltage, so that voltmeter is going to read 15. The current up there would be 3.75, and then on the bottom 5 amps, and again full voltage down there. So magnetic fields cause the space to be modified around the vicinity. And we talked about how magnetic fields are separate from electric fields. Magnetic fields are caused by the spin of the electrons. We can have current passing through a wire, and it produces a magnetic field, right? But they're separate from electric fields. And so you can't have like a monopole. You can't have a pole on its own, because it's the way the electrons are spinning creates the magnetic field. And so what I had the folks do in class is try to draw what the magnetic field looks like through this magnet. Remember, it goes inside and up and around. So yeah, I'll go ahead and pause the clip and see if you can remember how to draw it. And when ready to check, you can hit play. All right, so they're going up through the middle and then out of the north into the south. And then it's a continual loop around on both sides. And it's symmetrical like this as long as there's no other field interfering. Okay, so when you saw a magnet in half, they just become smaller magnets, right? And that's because all the different parts of that magnet are, the electrons are spinning in a certain direction, and that's what's creating the magnetic field. So you can't just like isolate a south pole or something like that. And then only a few materials, few metals are magnetic, and they can become magnetized where you can get all the electrons to spin in a certain direction. And those are called ferromagnetic materials.